First of all, welcome to the first non-closure Lisp talk for today. Emacs as my canvas. So the outline is first introduction into the topic, then basics. We need to understand the demonstrations, and then a project I've started recently, and wrapping up what I've learned from this project and how others can contribute to it. So, as to myself, my name is Vasilij Schneidermann. I'm 23 years old. I'm an information systems student. I'm currently having an internship at Untitled, where I'm writing Ruby on Rails code and closure scripts. And on the side time, I program in Chicken, Emacs, Lisp, and many other languages. I'm of course on GitHub, including all my projects. And I have a blog, emacssource.com, where I write about all the horrible things I find inside Emacs, just to have some platform to put them on. So, what we'll be covering today is of course Emacs, an extensible Q1-induced platform for everything that has got to do with text. Q1 is a term coined by Steve Yeager. It means that what we're speaking of is a system, a special system that just feels about right to interact with. Whatever you do, it is designed the right way, it doesn't get in your way at all, and you can extend it. It's like, for example, Microsoft Word with VBA or IPython or various Ruby systems or Emacs, for example. This is why it's relatively fun to hack on. But there are very little graphical demonstrations. There's of course the well-known Tetris Easter egg, which you can call by using MetaX Tetris and Snake and Pong and many more. But these aren't really graphical. They are basically just text with a tile associated with them and nothing really special. It's very much unlike what you do in graphics programming. And I've tried finding out what ways there are to do graphical demonstrations in Emacs and what you need to do your own. So yeah, let's change it. I hope that this talk will inspire many more than just my own. And yeah, so first of all, why the hell am I doing this? And answer to this is just because it can be done and because I want to improve my abilities basically. It doesn't have really anything else to do than with learning and getting better at this. And I hope you will feel the same about it. So, back to the basics. First of all, how many people in here know what Emacs is? Okay, great. How many of you use it? Wonderful. How many of you are using Emacs Lisp for customizing Emacs and writing your own scripts? Okay, that's a bit less. Yeah, and how many of you have written a package and contributed it? Okay, that's fair. Okay, so I think I can skip this, but I'll still keep it for the body. First of all, what we're talking about is text editor from 1985. So it's about 30 years old now, and yeah, it's been ported to all kinds of platforms of its time, like Microsoft DOS, for example, or many various Unices. And it's mostly implemented in its own extension language, Emacs Lisp, which gives it a few interesting abilities, like that it's extensible at runtime, and that it can introspect its state at almost any time. Some things you can't really extend, like the way its redisplay operations are implemented, or file primitives, or anything of that, but most of them aren't as interesting as the text editing, for example. So, how is this actually done? You have to consider that the basic data structure used in Emacs all over the place are buffers. They're basically two strings and a gap between them, which is why the implementation is called gap buffers. You can insert text at the beginning, at the end, and the text parts grow towards each other, and once the gap is filled, a new string is allocated, and you'll notice a small pause, but other than that, the editing just goes on. And buffers can be used to represent both files and text in memory. So if you, for example, open a file, it gets loaded into a buffer, and you can edit it until you save it, then gets loaded back to the file again. They're used heavily for text processing and for everything that needs something temporary to work with. You don't work as much with strings as in other programming languages, but almost exclusively on buffers. It's because the API for them is much more convenient. You can, for example, just move forwards, backwards, do basic parsing and delete parts of them, and use them as a mutable array, for example, like in other languages. So buffers can also support text properties. They can be attached to both strings and buffers, and they're basically property value pairs that you can attach to a range of characters. So you can, for example, specify that the first 5 characters in your buffer have a fixed property with the value of error, and that would cause Emacs to highlight that part of the text as if it were an error. So some of these properties are pretty special. One of them is face, as I mentioned already. The other one would be, for example, read-only, which would cause editing operations to fail on them unless you do something special. So the property we're interested in for this talk is the display property, because it allows using special features of the display engine. And it is all very well documented in the ELIS menu under special properties and the display property specifically. So the display engine is very basic, which is understandable. It's from the 80s, of course, because it assumes the text is laid out in a grid. If you compare it with the browser, it's a totally different story, because in browser it's just a tree, which can be arranged freely and modified easily, but there's a grid, and therefore a display property was introduced to allow for exceptions in this. You can, for example, cause the text to be displayed with another line height than usual. Or you could, for example, use an image descriptor, and therefore get an image displayed instead. So you have lots of cells which are twice as tall as they are wide, and at one place you'd have an image instead, which would occupy the whole cursor, but otherwise the text display stays the same. So you could use that to insert an image into a buffer with the following code. You'd have an insert, which would need a text as argument, and you'd use the propertize function to turn a string consisting of a single space into a propertize string with a display property. And for that we'd use a special list, starting with image and getting a few arguments, like that it's got a JPEG file type, and that it's loaded from a file known as keyboardcat.jpg. And if everything would go right, you'd have keyboardcat inserted in your current buffer. So that's the most basic part of all the magic we're going to see, inserting the propertize text associated with an image. So Emacs supports, of course, more than just JPEGs. It supports PNG files, which is very common. You'd encounter these files when loading something from disk. You can use GIF files. The support for this is relatively recent, but newer versions even support animation, which you can toggle and suspend. Then there are other formats that are easier to generate, like XTM from bitmaps. These are actually bit arrays, which you'd use for that, and XPM and PBM for the textual variant of this, which would allow for more colors. So SVG would be an XML format for vector graphics. PostScript and TIFF, well, I don't think anyone has ever used these seriously, though maybe there's an exception in the Emacs sources, because after all it's about 2 million lines of code, so who knows, maybe someone would use it. And there's a special exception, the ImageMagick image type, which would support any format the ImageMagick library supports, but with a few extra tunables, like for example the display's height or rotation or other specifications of that kind. Okay, for the locations, you can use images in other places than just buffers. You can, for example, put them into the mode line, which is the line at the bottom you see right about the echo area, or the header line, which is the equivalent at the top. Okay, the echo area, of course, as well, and tooltips, but only non-native ones. Native tooltips are mandated by the toolkit you'd use, which would be, for example, GTK on Linux. But if you deactivate that, you can actually get images in the tooltip. Okay, so for the next part, you can actually deal with mouse events and tooltips. The support for that is not limited, but it's actually there. It is used all over the place in Emacs. The mouse generates movement, click and scroll events. The movement events are usually ignored, but you can use a special form to track these. This is a very CPU-intensive operation, but still less CPU-intensive than in a browser, for example. So you could build a color picker, which takes less CPU ticks than the same thing in the browser. I've actually done this for my talk last year, demonstrated it at the time. Tooltips can be triggered with another special property, namely help echo. And cursor changes can be changed with the cursor property. Tooltips can be images, as mentioned before, but of course text, which is what they most of the time are. It is possible to write a mouse handler if you use the map property in the image descriptor. This means that if you hover over special parts of the image and click on them, you can run different code depending on where you've clicked. Maybe you have seen this in image maps, or in image map tags in HTML, but it's come out of style lately, and yeah. So you can alternatively go for another way, namely binding a command to the mouse event and examine the position instead. This is what I'm doing in one of my demonstrations. Okay. Finally, we've got timers. Emacs is still, despite all these tricks, a single-threaded application. It has some features which make it appear as if it weren't the case, but these break down if you do anything more advanced. And timers belong to this category, and they always run on Emacs. Just now hasn't got anything important to do, like ins idling. So there is a list of timers which you can run. These can be either idle or regular. The idle timers are run with nothing has happened at all in the time, like you have left the editor for 300 seconds, then you get an autosave. Or they're actually active and always run after a specified interval. And yeah, this can be, for example, used to make sure that after some time auto-completion pop-up appears or disappears. So what you have to look for is that you're not using too many timers, because if you do that, then Emacs doesn't really have any time to idle, and then it starts doing funny things like flickering your cursor. If you've ever seen that, chances are somebody screwed up while writing a package. I've seen it a few times and had to fix or switch packages after this. And yeah. So let's go for the actual demonstrations. I don't know if you've ever seen this, but this is one of the more known ones, yarn mode. Someone basically replaced the tracking of the part of the buffer you're viewing with yarn-cat, because why not? Why not? So as you can see, yarn-cat moves back and forwards as you scroll through the buffer. It is pointless, but so fun. I've heard some people use it actually for their daily work and put it in screenshots on the blog. There's an extra animated type of it. So if you see that? You see how it's moving its tail? I mean, yeah. It's basically everything that's wrong or right with Emacs hackers doing that kind of thing. There's unfortunately no sound support. This is probably because it's not simple to do this in a proper way. There's sound support for synchronous playback, but that sucks because your editor will block it while it's playing. And asynchronous playback would only work if you have another application to do that, but there isn't anything really cross-platform installed everywhere, so this route isn't really used either. Maybe FFI or modules or anything like that could enable that, but I don't know. It would be probably overkill for this. So yeah, this is by the way not the only one. Someone made reduce these graphics from the prompt of eShell, so that every time you enter new commands, you see yarn-cat in the prompt. But I won't demonstrate it this time. So yeah, back to this. Next demonstration. So yeah, we've seen somebody replaced the part of the mode line. So some crazy Russian decided to do more than that and replacing the entire mode line with SVG in this case. And someone else made it more popular by introducing actually good-looking themes for that. So The mode is, if you don't know yet, it is a list of segments which can be text or things to be evaluated, like a symbol or actual Emacs list code. And here we basically with a single image, it's a mouse handler so that you get tooltips, but otherwise it's completely generated and takes quite a bit of CPU time for this to work. So yeah, I've prepared one of these, and it's there. See that thing with the mustache? Yeah, that's an SVG model line. It has a single tooltip. Unfortunately, I haven't implemented these position-sensitive tooltips yet, but I could probably add it in a pull request or something. And yeah, it is pointless, but I think it's sort of cool too. And yeah, props for making that and actually doing cool themes of it. Okay, so for the next one, VGX, this is a bit different because this is existing code from Emacs. If you don't know yet, Emacs is a fork of Emacs, one of the few forks of large programs that actually succeeded. And it was made because the company, Lucid, did want to use Emacs as basis for the IDE, but have run into technical difficulties. They initially planned to fix these in Emacs itself, but Richard Stallman didn't agree with their ways of doing this, and yeah, so they decided to fork it eventually after a long debate. And one of the interesting features of Emacs, which is dead now by the way, if you plan on using it, is that it supports using a so-called background pix map. That means that you can use a graphic and tell it to use that graphic for the background. So you can have some Windows 98 style tiled backgrounds in your Emacs if you want. And yeah, some crazy Japanese guy ported this to the new Emacs for all kinds of versions of it. And yeah, you can apply this patch to it and actually load a background image. The location for this is a bit more complicated than I'd like to, but it works. I've tried. I've actually done a ticket to support loading something else in files from disk. So it supports strings as well, and yeah, animation doesn't work. You can't do anything else in tiling, so you won't have anything like Flippy in this, at least not in the foreseeable future, which is probably for the better. And I've prepared a tiled display of this. It's a bit disturbing though, so beware. Yeah. I don't see why anyone would use this either, but I still believe it's pretty cool. Okay, so to come back, these were 3 demonstrations of more interesting demos from outside. I've made 3 of my own, which I'll present shortly. Okay, first of all, SVG 2048. I hope you remember 2048. Maybe a quick poll. Who has played it? 2048? Okay, yeah, okay. In case for the rest who didn't, it's a neat little game. You have a grid of 4 × 4 squares, and yeah, you can move them towards each other, squares with the same number, merge into a higher one, and your goal is to go from 2 and 2 to 2048. And yeah, there were many mods of it, like Fibonacci numbers, or going the other way around, or for 4096. Many Emacs people did an ASCII version of this. I've once done research and found 4 different ones. So I decided to do something different and do something graphical, looking very much like the original. I expected this to be hard, but it wasn't. There's already at least 2 libraries for generating XML from Lispy data structures. And the rest of all is deleting an existing image, inserting a new one, and that's it. Maybe some game logic, but it's about 600 lines of code I've written for that. This demonstration is purely event-driven, which fits very well into Emacs model. You press a key, some calculation happens, it does something. And this goes on for the entire game. This was made possible because I haven't included animations yet, which I maybe will later, once I figured out how to use timers without spawning too many of them and grinding Emacs down to a mod. So I'll open the demonstration of it. So, yeah. I don't think there's much to be said about it. It behaves like the original. For example, if I move down, it merges two tiles at once, here another one, and yeah. I don't think I'll play it until I'm done, because that would take a little bit too long, but I can ensure that it works. If you don't believe me, feel free to download it yourself and play it on your own. I haven't packaged it yet, because I have a dependency on some self-made package for basically a shitty database that works in memory. But other than that, it should just run. So yeah, to the next demonstration. I have made XBM live. That was because pretty much everyone at the place I work at did have to do a game of life in their preferred programming language, and I didn't yet at the time, so I decided to make my own, and I thought, why not do it in Emacs, and why not try something different than SVG, because I can't really stand XML and want to try something different. And XBM, especially because it's always built-in monochrome image type. You have it everywhere, you have a graphical display, even on Windows. And that is pretty cool. You will also have the proper colors automatically, like foreground color and background color of the buffer. So I did that to find out how suitable it is to actually use bytes and manipulate them directly. I found out that bool vectors are kind of weird, because there isn't much support for them. Only some operations, for example, doing a logical OR and XOR combination on them, but yeah. This was the first time I've actually used timers for this, which told me that they are a bit weird to use, but otherwise very useful. And that told me about the UI I expect. I've built in a few extras, like enlarging the tiles or making the demonstration faster, slower, inverting, loading other patterns into it, and yeah, I think I'll demonstrate shortly as well. Something more interesting, you should all know this one. If not, write your own, try it, it's a lot of fun, no matter what programming language you do. And yeah. And now it should walk around, if I've done everything right. No. Okay, anyway. Yeah. Okay, and now for kind demonstration, I did decide to do an actual game, because the other ones were more like toys, and yeah, I like Tetris. It's one of the few games I can actually play well, because I suck at other games, and yeah, I especially like the NES variants, because it is very simple. It has pretty nice graphics, considering from the time it comes from, and I wanted to try out XBM for the graphics format, because it is textual, so no bitmaps, no XML or anything. It's relatively simple, and it supports colors, but in bitmaps, so why not try that out while I'm at it. So this is a relatively simple game, but it involves a bit more work, because it needs to run at a constant 60 FPS to work well at all. So I'm wondering whether this kind of thing is doable in Emacs Lisp at all, and I put it on GitHub too. This is, unlike the other two, an incomplete version of it. I have in fact not committed the one I'm going to show now, but it should work if you know what you're doing. So to answer the question, yes, you can actually do something useful with it. As you can see, you can move the piece just fine. New pieces fall, and yeah, rotation works as well. So the basic game is implemented and runs at a constant 60 FPS. No graphical glitches or anything. And yeah, it's not much beyond that, because I haven't implemented clearing lines or anything like that, but I just wanted to know whether it's actually feasible to do something more advanced than the usual puzzle game in Emacs. So yeah, I've learned quite a lot more from what I'm calling retwist than from the other ones, and I'm going to present in this section what exactly it all has been. So yeah, first of all, retro games, so all old games are Surprisingly interesting resource to learn from, because they had to make very, very good use of the resources they were given and the consoles they were running on. So you're bound to run in unusual implementation techniques, which are still relevant in the platform like a text editor after all, because you can't do just something like have sprites that you can move freely around, like in the game talk at the beginning of today. Or you can't redraw the whole image. No, you have to do things in a more clever way. So you don't have a game engine either. Pretty much everything done on these consoles was custom tailored. And yeah, since I'm playing a retro game, I thought it would be a good approach to go for. There is one exception, of course. Someone tried doing a game engine in Emacs Lisp. It was DTO. He called it RLX. But he has abandoned it, so it's only there as a gist on his GitHub account. And instead he went for redoing it in Common Lisp and redoing Emacs while he was at it. So I have sort of an Emacs-like environment where I can write games in it. But so far only he has made games in it, but maybe you'll find it interesting as well, if you want to do this the proper way instead of getting the most out of Emacs. So yeah, I've run into a few impedance mismatches while I was at it. For example, you should under no circumstances use a game buffer changing function outside the buffer. Because if you do, and you click your source buffer, for example, it turns read-only in the best case. In the worst case, it deletes actually your whole contents, and if you haven't another instance open with it all, or VCS, as I had, well, you've got a problem. So yeah, other problems were that you have a buffer point, that is the account position in your buffer, but you have a window point as well, the display position in the buffer, and these can be different from each other. Finding that out cost me a bit too much time. Then the act of displaying windows is sort of weird. You have an entire API implemented in Emacs for customizing the way windows are displayed, but there are things not using it and doing it so that you can play the game actually is weird. I've resorted to writing a package to make customization of that easier and put it up on GitHub in the meantime. And yeah, so the act of deleting and inserting an image is fine and dandy. You won't recognize any graphical glitches while doing so, but it doesn't play well with other mechanisms like scrolling or the region or clicks or any other of that kind. You can, for example, end up, if you are popping up a debugger, like which very often happens, then the image is scrolled up and you don't see anything, because Emacs scrolls up only a whole character at a time, and if an image is there, it is much larger than the line normally is, and it just seems to be gone until you scroll up again. And if you have deactivated that, you run into another problem of that kind. So yeah, region, you can inadvertently select the region, and if something is updated 60 times a second, it's kind of hard to deactivate it again. Clicks are another thing I've somehow solved simply by attaching a property to the image to always put pointer to the end, so it looks sort of okay now, and yeah. Something that just felt wrong to me was putting a game loop inside an event loop. It can work, but it only works if the game is the only thing that runs at the moment. So if you want to try it by demo, I advise you to not do it in an existing Emacs session, do something else that is already expensive. So yeah, and timers were definitely not made for this purpose of running very often, but they can be fortunately made to work well enough. I am later explaining my approach. I went for this, which seems to work now. So yeah, let's get to another topic, data structures. How many of you know what Lisp means for viewing this slide? Okay. Well, yeah, Lisp processing. So it isn't really surprising that a Lisp processing language has special support for doing things to lists. But I did sort of expect to have more support for other data structures, and you are bound to be using vectors in games at least very much. Hashes not so much. You can get away with using a property list or anything, but for vectors it was kind of painful. If you compare this with Common Lisp, for example, or Clojure, this is a very different world. In Common Lisp you would have polymorphic functions that can work on more than just a list. At least all I've checked it work on vectors as well. In conclusion, we have a more powerful abstraction of sequences, which can be used for vectors, hash tables, sets, and many more. And you have a useful API tool for that, and laziness, which are all very, very useful for that kind of thing. But I wanted to stay in Emacs for this all. So, yeah. What did surprise me was that this did extend to hash tables, which are practically nowhere used at all. Instead, you would use association lists or p-lists, which have the problem that lookup isn't efficient in them unless they are small, and strings. Manipulation of strings is a major pain in the ass. So yeah, there are no sets at all, and structs are a hack from the CLlib, which are actually vectors holding a bunch of methods made by a complicated macro. So yeah, everything you see is using lists, even where sets and hash tables or vectors would make more sense. So what did I do? I started writing vector functions, because I needed them, and yeah, one solution would have been coercing a vector into a list and back, but that would have been okay for something like a normal package, but not for a game, because this happens very, very often, and otherwise I would have taxed the garbage collector way too much for this. So I've written my own functions and macros, and I'm considering to release these as a utility library if there's any interest in it. So far I haven't found many people supporting this idea, although there are other utility libraries like dash.el or s.el. But yeah, here some of these you'd expect to have in other programming languages. Like there isn't a vector copy function. Instead there's a copy sequence function. I wouldn't have guessed that copy sequence would copy a vector as well, but it does. And why it does, it doesn't do a deep copy. So we have a separate function for that too, copy tree, which could be used at this, but if you don't use the last option argument at the end, it won't work on a vector, but instead on a list, or rather a nested list. And yeah, creating a nested vector is simple enough. You would assume that it's enough to just do a vector with a starting element of another vector, but if you do it that way, then you'll quickly notice that these elements are shared. If you modify one part of that initial list, every other list present in the vector will change as well. So yeah, my workaround was to create a list, put a separate vector into it, and then turn these into a vector. Alternatively, you could create a vector at the beginning and then iterate through it, but whatever. I didn't find any noticeable difference between these when benchmarking that. So the most advanced thing I wrote is a macro for iterating over a macro for iterating over a vector. It works pretty much like the other list iterating macros, and yeah, you'd have two symbols. One of for the current spec and one for I. You'd go over these, execute a body, and yeah, continue after that. So nothing special to see there, but I don't want to write that kind of thing every time I need to iterate over a vector, and would have loved to see that in the language on its own. So yeah, next part. I had a completely different problem, because when I had to create a string to generate an image. So generating a string from a vector would have been an option, but then I would have created a small string, then have created a bigger string, and so on and so forth, until I've created a large string, and that didn't sound really well and did consume too much garbage collection resources, so I went for a different approach. And remember that strings in Emacs list are actually mutable. You learn from other languages that you shouldn't mutate a string because it's sort of icky. You can't really reason about what will happen and anything, but it works well enough for this approach. So, as you can see, lower bytes have changed there. We go from one kind of checkerboard to another one, and that works well enough. So, yeah, next part, I did try my newly written string mutating function, and found out that if I were to create a whole, if I were to draw over that string for every cell in this grid, it wouldn't be fast enough. I did something more conservative and tried at 20 FPS, but that just blocked up Emacs. So I went low and found out that this would, in unbyte compiled mode, go to 10 FPS, and byte compiled to 20 FPS, which was not fast enough because it was after all targeting the original speed of 60 frames per second. So yeah, I needed something more clever than this, and I didn't want to do like in the original game, where they did actually figure out in which order to change the grid and for the individual pieces. So I did look at some other library, at React. I don't know how many of you have heard of React.js. Okay, yeah, for the rest, it's a library released by Facebook, which was done to do something against the craze of new and never-ending MVC frameworks. It basically meant just the V part in this, the view. Because they've realized the common problem there is that you have a DOM, which is a tree in the browser, and you are mutating it over and over again. And figuring out what parts to mutate of it to make it as efficient as possible is difficult. So they did think up a clever diffing algorithm. And that diffing algorithm takes a virtual DOM, which was manipulated by the framework, compares it against the actual DOM, and then changes the parts that are necessary to change. So it's very efficient, it works well enough for the apps. I'm actually using it at work too, and I decided to implement a poor version of it using snapshots. I did the snapshot of the grid, I commented the current one, went through these, and redrew just the differences. It is relatively ugly compared to the original thing, but it works very well. Much better than I actually anticipated. The implementation is relatively simple. We have an empty variable containing a list, containing a future list of coordinates that have changed, and we go through y and x to the height and width of the board. We compare then the old piece that was there with the new piece, and if they differ, we push the coordinates and what the new char will be at that point into the list of chords and then return it. And this function is used later with a different system. If a dirty flag is set, then we figure out these differences. We split it up in the coordinates in the char, then we save the current tree, we deactivate the dirty flag, and then we repaint just these differences in a separate image. So we're doing the step that we mentioned before. Make sure the buffer is no more read-only, erase the contents, and then insert a new image at that point. And that is done every time it's needed, every time the dirty flag is set, and there are actually differences. Okay, so for the final part, I had to schedule events. So I've told you about the built-in timer support, and that I basically have to outsmart it to avoid the dreaded flicker and performance going down. So I did sort of re-implement it, but in a smarter way. I have used a list of vectors, each of which represents an event. And the game has an internal clock that is advanced every frame. So if 160 per second have passed, that count is incremented by 1. This will eventually lead to an integer overflow, but this doesn't really matter for the thing we're doing, because we take every event and take the current time, modulo the interval, and check for the remainder stored in that event. And if it equals that remainder, we can run these events, the eligible, later. If we want to do an one-shot event, this is simple enough. We just remove the event after it has been run. This did work too, and there has been no flicker at all. So yeah, the code for this is similarly easy. We have an empty list. We go through all events. We check for the interval time. We take it modulo the we take the count time. We take it modulo the interval. And if it equals the remainder, we push the function to be run to a list of tasks and return it for later consumption. And this is basically the game loop here. We go through all the tasks. We draw the board and we increment the time. That's pretty much it. The real code is a bit more ugly. I've trimmed it a bit to make this easy to explain, but yeah, that's the basic way it works. So, yeah, to wrap this up. Final question, was this endeavor worth it? Yeah, definitely. For me it was. It was rather bothersome to work on the deficiencies of Emacs there, but it was overall pretty much a lot of fun. And yeah, I've learned a lot of this, like why we haven't seen any AAA game yet in Emacs, because it is sort of hard to do, and I doubt this trick I've used for Tetris would work well enough in something 3D. It would probably only work for 2D games with using tiles and not much sprites. And yeah, but maybe it could work if you would use vectors and recreate something like the very first shooter ever made. I don't know, you can Google this and see that it has vector graphics in black and white. Maybe that would be ported to Emacs if anyone wants. But yeah, if you found this interesting, I would be very happy if you could join me in this, because I definitely wanted to do a few things more. And I did compile a list of interesting things that are a bit more advanced than what I've presented here. Like the very first thing I want to do would be a GIF authoring environment in Emacs, because pretty much all of my projects get an animated GIF, and editing these in both Photoshop and GIMP isn't nice at all. I've worked in Photoshop for years, and while it's nice for images, it isn't so nice for vectors and pretty bad for GIFs. GIMP is slightly better, which is unexpected, but not much better. And there are command line utilities for joining and splitting GIFs, so and some for optimizing them. And you could implement the rest in Emacs, like a preview, inserting an image. You could display other images to be joined at the bottom, and you could have a better environment, I think. It's certainly worth a try. So for the more outrageous ideas, we could have a bitmap editor, if someone would dare. The basic support is there. You can use the SVG type to draw widgets and then insert a bitmap into it. This is a relatively new add-on. It has actually been bugged in current Emacs versions, and I've complained, and now it's fixed in 25, which will be released soon, I've heard. So maybe someone will go with this. A vector editor would be a bit simpler. There's been a demo made by the guy behind the SVG mode line. He has actually made a vector demo first, where you can drag vectors with the mouse and edit them. For pixel art, I have put up a demonstration how this would look like on my own website. Just a moment. Yeah. This thing there is CSS3. This is no image. As you can see, there is no view image, because this is just CSS3 with a bit of animation. This can be proved easily by viewing the page source, which is just CSS. And yeah, this was very, very fun to do, but sort of bothersome, because I had to actually do this in GIMP, and then look at the grid and translate all the values, which are just box shadow elements, into CSS. And it's a bit much of that, and I'd like to have a tool for this, but neither GIMP nor Photoshop have CSS3 export, so why not do this in Chicken or Emacs or whatever? Or maybe combine both, like Chicken for the image decoding and Emacs for turning it into CSS and editing. And yeah, creating more of these. Maybe an image obfuscator. Maybe. It's kind of the idea that could get you GitHub's favorites or anything like that. So yeah, Kickstart editor maybe. Okay, next, demos. I don't know if you have been at scene.org, but there are demos, demonstrations done by individuals who try to squeeze as much as possible into a few bytes and turning these into impressive images and sounds created at runtime. You can't really do the size part yet in Emacs, but you could maybe display something more graphically interesting and animated in it if you can solve the inherent problems in doing this in real time. And yeah, sound will always be a challenge. I did a short commentary on what you would need to do asynchronous sound, and yeah, someone did ask me whether I want to do that kind of thing, but I don't know the mathematics these guys use for their tricks, so yeah, maybe later. And finally, for something actually relevant, which I use every day, image preview tooltips. I've seen these on 4chan, on Imager, and a few other platforms. These are basically, if you hover over a link that leads to an image or a GIF, you get, after a short loading time, a tooltip displaying that thing in line. And that kind of thing would be very handy to have an RSC client, but would need a bit more sophisticated code to work well. So yeah, this would be one of the few practical things I would have in mind. And there's of course more. So if you have any ideas, contact me. Okay, that's the end of talk. Any questions? Okay, thank you.